Well, thank you for that very nice introduction. It's a pleasure being here. I think the last time I was in New Haven was sometime in the 60s, so most of you weren't even born. But it's as beautiful now as it was then, even more so, I would say. So I'm going to talk today in the Okun Lecture, as you heard. I think we all chose the same picture because we're looking around for pictures. And let's see, oh, here. Okay, I'm going to talk about nowcasting, and I'm going to talk about Google Trends. And I'll give a little preface by saying I'm kind of neutral with respect to the methodology. What I want to talk about is the extra variables that you could get from utilizing various kinds of online services. And Google is one I know best, of course, but there are others that I'll refer to as time goes on. And about 12 years ago, I couldn't believe it was that long ago, but 12 years ago, I gave a talk in Australia, the Australian, something like that. And I called that Predicting the Present with Google Trends. What's getting feedback or something?
Just gonna give it a little extra.
Oh, okay. All right. So wrote this paper called Predicting the Present with Google Trends. And the idea there is what we've now come to refer to as nowcasting. So I switched the vocabulary to talk about that, but it's the same general idea. We're trying to look at behavior in the economy or something using data from Google. And that little paper, that little talk got 3,000 citations in Google Scholar. So I was really surprised by that activity. And there's been lots and lots of work of people who have used Google Trends for doing various kinds of forecasting. And I'm going to show you some of those with the expectation or maybe the hope that you get to play around with this tool yourself, because it's perfect for undergraduate theses and all sorts of little interesting studies. It's really extremely useful for both serious uses and maybe a few frivolous uses I might describe. So what is nowcasting? So it's a prediction of the very recent past, the present, what's going on now, and the future of, again, usually a kind of a future that's very short time difference. Now, it's very common to see lots of data in business or in government for that matter, that's created in a continuous way. So the data is flowing in over the course of the week or over the month. And then they arbitrarily say, okay, we'll call that October, and then we'll call that November, call that December, and so on. And so they'll take this continuous flow and report on it on a monthly basis or yearly basis or quarterly basis and so on. So one thing that's become very popular, and I'll refer back to this in a few minutes, is how to estimate weekly GDP. Well, the challenge there is there's no such thing as weekly GDP. That's something of a barrier because you're looking at data that's released on a quarterly basis. But can you run it backwards in some sense and find out what's happening this month or this week? That's an estimate or forecast of what will happen at the end of the quarter when the official numbers are released. And that's become a very popular sport. The Atlanta Fed and the OECD are doing a GDP tracker that allows you to look at this high frequency component. All right, Google Trends. Okay, this is a question for the audience, especially the students. Which day of the week are there the most searches for Hangover? Okay, so I want to see a show of hands. Sunday? Oh, okay. Monday? Tuesday? Wednesday? Thursday? You got a few party animals over here, just a few. But Friday, and then okay, we got a few there to prepare for early weekend. But how would you find out? If I ask you this question, how would you find out the answer? Well, what you should do is you should go to Google Trends, which is a service that we offer, and it shows us an index about different queries that people might issue. And here we could look at queries for Hangover. Okay, that's the blue line. And you notice it peaks, it's a very cyclical series and peaks every Sunday, just as the majority of the people responded. And that red line, that's actually searches for the term vodka. And it just precedes the hangover component by 24 hours. And any of you that are teaching Granger causality in your courses may want to use this example because it's a very nice example of how you can have a simple model of time series structure where you've got not really a causal variable, but a predictive variable of some economic series. In this case, hangovers and vodka. So, but there's more stuff. Here it is on a geographical basis. And if you look closely at that chart, you will discover that New York is the hangover capital of the US, maybe not too surprising. And over there on the right, there are examples of the queries that people have issued that contain the term hangover. And some of them, you see, if you scan down there carefully, you see there's a lot of interest in curing a hangover and hangover remedies and so on, but there are things here about the movie. So you can't necessarily say, oh yes, these are the important queries. The important queries are things that they're the most descriptive of hangover, ones with the highest rating there. So we have this score as well. And are they increasing, decreasing? A whole wealth of information there about that particular term. And this is all due to the fact that you can use Google Trends. I mean, what I did to look at that series is I just went to trends.google.com, typed in hangover, and then I got that wealth of data, which you can all save. Or if you're doing some serious and important work, you can get on the API and do this in bulk. So you can look at a lot of different terms by using that. So what are some of the features? Well, there are good things and bad things about it. Only the popular queries are looked at, and they're for distinct IP addresses, so you can't sort of issue the same query over and over again. What happens is they cache it as the first time it's asked, and then everybody else who asks that question over the course of 24 hours gets the same results, and then it'll refresh the cache on the next day, which makes a lot of sense, because if there's some event, a sporting event or a business event or something, people will issue queries on it and be much the same query. You only look at aggregate data, so you can look at it by country, by state, by DMA, that's direct marketing. What's the A stand for? Direct marketing something area. And the metro, the city as well. So you see the issues where this, like the one I showed you for New York, cases where you see the geographic variation in this topic. So the largest value of the index is normalized to 100. Other values are measured relative to the largest index. Data is a sample. It's cache and refresh daily, as I said. There's an API available. There's a cap on the number of daily downloads. You can't go download millions of terms. I forget what the cap is, but it's fairly generous. And you can also look at topics and categories. And I'll give you an example of that in a few minutes, because you don't have to look at the specific term, but you also can look at the term of which that's a aggregator for it, basically categories and topics, which are slightly different, and I'll refer to that when I get to that point. And last thing, you can look at queries that occur on the web, the images, news, shopping, and YouTube. So there's a whole wealth of observations. I'm just going to talk about web search because that's the one that's the most compelling and interesting to people. But if you were interested in images, you could see the image queries that people issued to the image search as well. So those are the features to Google Trends. And now, a few words about nowcasting and forecasting. John Patel, who's a internet guru, I guess, he said, Google's a database of intentions. And you get the idea. The idea is if you're thinking about making a decision, maybe buying something, going somewhere on vacation, getting something to eat, you might go to Google and you might ask it queries about where you could find good coffee, or where you could find enjoyable vacation, etc. And so the idea is the intentions usually precede actions. They're lead up to the actions. And that says, well, it's pretty reasonable that Google queries might be a leading indicator. It might predict actions just from looking at the intention that's implicitly there for the Google query. Okay, so the idea is that it's not so surprising. You can see actions related to queries with the kind of intermediary of being the appearance on Google. So lots of searches lead to very recent or about to occur actions. So where do I get some coffee, or where's coffee near me? And that's the sort of paradigm case of nowcasting. I want to look at what's going on now. But there are some cases where the intentions occur far in advance of the actions, where you have some decision that's going to occur as a response to your questions in some ways, but it might be months. So buying a new house, that's a process that takes months to happen. People would have all sorts of real estate queries that would be predictive of that particular action. Buying a house, buying a car, same sort of thing, maybe less of a consideration period. But if you're interested in things like, well, how did this shortage of chips affect the auto market? Then you might want an index for people who are interested in buying a car. And so Google search is a place to go. Vacation in Hawaii, tourism, lots and lots of tourism issues boil down to this kind of behavior where Google is showing possible places that people are considering vacationing or tourism, and then what the actual outcome is. So sometimes you can get predictions that are a month in advance. You can forecast there's going to be a lot of people visiting some particular place at some particular time, and then you can then say, well, this is what's going to happen 6 months from now. Right now, there are people planning out their summer vacations in south of France or the north of Italy or whatever, and that it turns out, as I'll show you, that turns out to be indicative of where they actually go. Not too surprising. All right, those are some quick points about it. And I should say the same thing applies to many other real-time economic metrics. So let's look at the business of releasing economic data done by governments typically, or international organizations. They're revised as new information becomes available. And so it's nice to have as recent data as possible if you're concerned about doing some kind of forecasting or nowcasting based on that variable. So these are examples of daily average users of Google Maps, which I'm sure all of you have seen at one time or another. And there's an interesting story behind this. I'd done a little work with the Fed on real-time indicators of economic activity, and we had various ideas about what you could do and what the issues would be and all that kind of stuff. And then along comes April 2020, and COVID hits, and there's this lockdown issue, and the people at the Fed wondered, how big a deal is this? Is this a big deal, or is this not such a big deal? Because monetary policy would respond as quickly as possible if it was a big deal. And here's a couple of cities. These are metropolitan areas. This is daily average users. And you can see the automobile traffic, or vehicle traffic in general, users of Google Maps, that fell by over 50% in just a few days. It was incredible. And so when people opened that folder and looked at these charts, they said, oh my gosh, this is really a big deal. We better plan a very strong stimulus to try to counteract that problem. So we then released daily average users for many months. It was just shut down a few weeks ago, but it could be used again for getting a general measure of activity. I won't say just health activity, but activity in general, mobility by users, and that can be very helpful. We're getting a picture of what's going on, which is how it was used. So there's other data. There's things like financial data. If you look at some of these forecasters, they're using financial terms as a forecast variable. credit cards. Credit cards are fantastic. Not Microsoft, but some of the credit card companies have issued cards that give you data on how much is spent by region and by product type. And that turns out to be a very useful deal. We can correlate that with the Google data as well. Payroll data, API, ADI comes from that. Traffic, as I mentioned earlier, queries as have been typed out, news stories, all sorts of things. But the one that is really the topic of this discussion is the Google Trends, because it's very high frequency. You can actually look at hourly queries by hour. And it's also something that's free and is available for use. And lots of scholars and lots of people have used Google Trends to do this kind of prediction in the markets or the areas they're interested in. So you can think of situations where you're doing prediction estimated at a monthly frequency using monthly data. That's pretty dull, but that's what's in all the textbooks. You can look at estimating monthly using weekly data. So that's pretty easy because a month is just 4 times as big as the average weekly data. And then you could do the kind of interesting one, a weekly prediction estimated using monthly data, where you're trying to infer what the weeks look like, given that you know the aggregate. And that's where the Google really comes in. It's helpful because if you have any real-time indicator of economic activity, you could find out what the correlation of that is with the metric you're interested in. And then you can kind of work backwards, estimate a model and infer what the weekly GDP, for example, looks like using monthly or even quarterly data. Because the only official data in the US is the quarterly data, and everything else has to be constructed. So let's jump right in. Initial claims for unemployment benefits, very important metric. Am I right on that, right? That it's very important metric. Here's a little picture. The black is the initial claims for unemployment benefit. And that's what, by that, I mean people who are laid off and then go down to the unemployment office and collect, file for unemployment benefits. Those are the initial claims, and they're reported on a weekly basis in the US. So very high frequency for economic data. And you notice that initial claims peaks right at the end of each of those gray bars. Those gray bars are recessions. And you say, oh, wow, that's really neat. But what you forget is that economists get to define when a recession ends. You know? So we can pick it so it always ends at the side of this gray variance. And that's right. I mean, they look at a number of different metrics. The dating commission, they look at a number of different estimates, and then they pick a decision of whether or not we're entering a recession, leaving a recession, whatever. But a more interesting observation is here that that if you look at the unemployment rate, so that's the monthly rate, the headline rate for unemployment, the initial claims are something of a predictor of that. So you can look at something like 6 months, maybe more, 6, 8 months, something in that area. The initial claims are predictive of the unemployment rate. And of course, the unemployment rate is one of the most one of the most important metrics to use for macroeconomic policy. Okay, so what would you do if you became unemployed? Well, you'd probably go to Google and look up some information about how to get unemployment benefits. And over here on the right, I have a bunch of queries from Google that people issued that involve the term unemployment. So you can look at Michigan unemployment, Idaho, they're all administered by states. So that's why you're seeing all of that. Unemployment filing, where's the unemployment office? What do I have to bring to the unemployment office? All sorts of queries related to that topic. And then it's not too surprising, for the reasons I mentioned earlier, that you would see those queries on unemployment benefits are then predictive of the actual unemployment benefits that are occurring a few days later. It turns out the day, we can also do this by day, and Monday is the big day when people get in and file for unemployment. requests, and that's probably because they were laid off on Friday, and makes it easier to do. But that's how it's handled. So that's it's helpful to be able to predict what the initial claims for unemployment will be like in a few days or even a week or more. And the state level, I think, is still 2 weeks to do that. All right, so what we do here is we're going to build a set of tools, or I'm going to describe a set of tools that we built for prediction using trends. And as I said earlier, if you've got another measure, another way to do predictions, bully for you, that's great. I mean, we did it for our particular needs, and it's a nice set of tools. But there are lots of other people who are working in this general area, and there are lots of exploration of what these tools look like. So what we did is we had a model where we combined a Kalman filter, which is a prediction technology, with a regression model. So on the Kalman filter, you get to estimate the trend. Is it going up? Is it going down? And the seasonal components, how's it look over the course of days a week or weeks a month, whatever. And in the Kalman filter, basically, when you dig through what it's doing, when you look at its estimate for prediction of, in this case, unemployment applications, if you have a prediction this period, then your forecast is a prediction last period plus an error adjustment. If you overestimated, you knock down the threshold a little bit. If you underestimated, you lift it up. And that's basically what the Kalman filter is doing. There's a wonderful book by Andrew Harvey who describes this in great detail. There's a lot of neat things about it. Do K-step ahead prediction. Usually we're doing one time period, 1 month, 1 week, 1 quarter, whatever. And I think many of you heard of this, or at least understand how there are various ways to do this time series analysis. But we add an extra feature, namely the regression component. And what we do there is use something called spike and slab regression. And a spike and slab is a Bayesian method. It says there's a spike here. That's a probability that this variable is included in my regression. And conditional on being included, there's a slab. There's a estimated probability that that included variable takes on some particular value. Okay, so you've got the spike. That's it. Yes, 0, 1, included, not included. And then you've got the slab. Conditional on being included, what value is the best value for that, that predictor. So we fit the models using this Markov chain Monte Carlo, and we put everything together in that equation on the bottom of the page. The variable we're interested in, like might be the initial claims for unemployment benefits. That'll be a level, what level it's at on average. There will be a trend. Is it growing or shrinking? There's a seasonal component. How does it vary over days a week or weeks a month, whatever? And the regression. What are other contemporaneous variables from, in our case, Google Trends that are, we think, will be predictive of the initial claims for unemployment benefits, namely the queries on unemployment or unemployment office. All right. So that's what we do. And it comes out pretty neat, I think. This is just writing in an algebra. There's a level, mu at time t, seasonal, gamma at time t, regression, beta, time, those are the coefficients that are may or may not be in the final regression. And then we look at our evolution model for each of those particular variables. So that's the algebra, or that's the picture. And this was all constructed by a fellow named Steve Scott, who was on my team, a computational statistician. And he did all the difficult stuff, and I made suggestions for, let's try it on this, let's try it on that, let's give it this capability and so on. That was a good thing about being the leader. You could order people around and they would actually do, unlike faculty, you know, or something, they would actually do it. And so this is up at a couple different places, NVER volume on digital economy and so on. So this is not, you know, this isn't to memorize, it's just to see an example of what this Bayesian structural time series looks like. You suggest a state, SS, you add in a local linear trend. So that's one of the components, going to be locally linear. Could be different, right? But that's the standard one. You put in a seasonal, the number of seasons is 52. I'm looking at weekly data. We call that model. And then we write BSTS, Bayesian structural time series, says that Y, the variable of interest, depends on the states that I specified above. There's a list of them. That's the SS business. I'm going to use this data that I've got a lot of data that I think might be predictive of a Y, but I don't really know for sure. So I'm going to use this variable selection model that I alluded to, the spike and slab. And my guess is I'm looking for around 5 predictors. You know, could be more, could be less, but I think that's the kind of model I want. And the seed is just there so I can do reproducible, reproduce it later on when I made some change in the algorithm. All right, so now we'll start with the examples. And the first one is what I've been talking about. There's the picture that we saw. This is the BSTS model. It's pretty much the same as what we saw a minute ago. It's got a few extra things in it that I'm not going to discuss at this point, but that's what your specification looks like. All right, so we run it, we get this model. And on the right-hand side, we get a decomposition into these 3 different things: the trend, which is over there on the left, and the cyclical, which is a repeating pattern there in the middle, and then the regression. And we're seeing the regression doesn't do much in the initial weeks, but then it has this huge spike, and that's the 2008, 2009 recession. And what are the things that predict that big shock, or contemporaneously predict, right? What is correlated with that? And the answer is unemployment office, just as I said. So it's that unemployment office, that's a good predictor. The blocks, that turns out to be a game. That's not a very good predictor of the unemployment rate. Filing for unemployment, Montana unemployment, et cetera, et cetera. So you get a list of variables that may be predictive. And based on that, you could pair your list, or you could add more to it or something and get a model that you're comfortable with in terms of doing this kind of forecasting. And you can see, on a screen, these would be bigger and there'd be more detail that you could see, but still it's a pretty nice to have that decomposition. And so here's the actual and the forecast there, and the top and the bottom, the actual initial claims and the forecast, 1 period ahead forecast. We only have to predict 1 period ahead here. That's what the actual looks like. And then over on the right says scatter plot. And somewhere in the notes, I talk about how well predictive it is. So that model does the does the job for us. We can do out of sample forecasts if we want. You just freeze the cut points and then estimate up until that point. And after that, it's just running on empty. That is, it's doing the forecast based on the model that's estimated up to now. And the reason I have to do it that way is the Kalman filter itself is adaptive, but it's not doing any prediction in this space where I've got the forecast, the right-hand side of those blocks. So that's what that looks like. And what I can do, and what we've done looking at this a lot to understand how it works, is we compared 3 models. One is where we just use Kalman. So we just used the time series, so that we've got the cyclical component, we got the trend component, we got the level component and so on, but we're just going to use that. And the second one is where we use all of our predictors. So there are about 250 of them. I'll give you a list a little later on. And you can see how well that does. And it's selecting from that set of possibilities, it's selecting the X's, which are, again, going to be the most helpful, controlling for the trend and the other Kalman estimates. So we look at unemployment related queries. These are ones that I used my judgment to pick out from the queries, the ones that I thought were most predictive of unemployment. And I still say you can pick the ones you want, but I'm going to give you this very restricted set of explanatory variables. And the interesting thing is, if you look at that top chart, what that is that is a cumulative error chart. So the error goes up as you forecast more things. But look at that big bump, which is right around the time that the recession begins to show up. That's a little bump. I'm talking about this here. Up until that point, the economy was just running very smoothly. Everything was growing at sort of X% per year, whatever it was. And there really wasn't much difference between your models, because you got the same thing if you're using claims or if you're using Kalman or if you're using all of them or just a subset, not much difference. Well, then comes a recession, and then see this big bump in the error. It's gotten much more difficult to predict. And in fact, it turns out, if you go back and look at that previous chart, it turns out those predictors that I referred to earlier, those start showing up as being better than the time series, because they're capturing this period when you're seeing all of this activity. So you can do that for anything. So here's an example of housing. Here, instead of using the words unemployment, I use the categories. And so there's in real estate, apartments and residential rentals, property development, property inspection, those are queries that people, those are categories of queries that people ask. And it's a little bit, you see, you have this housing's going down, and then it just sort of skates along for a long time. And there isn't much growth in this cumulative average error, all right? But exact queries may not persist in the future, but categories will. And restriction to real estate, my restriction here versus what happens if I gave it a big set of regressors to use, of possible regressors, didn't make much difference. All right, really didn't make much difference. So this is what the out of sample prediction looks like. Same general idea, freezes the regression. Automobiles. Here's one that's kind of interesting. I don't know if you can see that. I can barely see it. Autos and vehicles, vehicle for shopping. That's the predictor that's the most effective out of all of these. But then shopping, swap meets, and outdoor markets, which I suspect, don't know for sure, but I think that's probably looking for used cars. All right. So we didn't distinguish in this between used and new cars. And then again, you can see what happens to the actual down on the below, and we look at the cumulative error. And now the auto and the all really are a big improvement over just the pure time series regression. So the fact that people are querying on these motor vehicle sales, that's something that's quite suggestive about what the future will look like, what the present looks like for the automotive industry. And I think with some digging around, we could probably do something about this used car, new car split as well. So let's see, what do we got here? Actual predicted. So this is the actual and predicted lightweight vehicle sales, which you can see fits pretty well. And this is using both the regression components and the other trend components, out of sample prediction again. Okay. So the next one is, this isn't something we did, but a very bright fellow at the OEC did, is he said, let's build a tracking index that tracks the GDP, or my estimated GDP of monthly or weekly variables. And I'm going to do that using only Google Trends data to make this prediction. And if you go there, go to the OECD site, and you will see their estimate of what the weekly data looks like. And then the red dots are the GDP, the actual GDP that's released on a quarterly basis. And you could do this. The great thing about the OECD data is it's standardized. So if you do it for one country, you've automatically done it for all the OECD countries. And the reason you want to use categories that I described earlier is because people speak different languages, and automobiles, or so there's another word for automobiles in French. So you can build that, and it works really very nicely. And so here's the predictors from the OECD P tracker. It's not all the predictors because I didn't have enough room to put them all on the page, but it's roughly speaking, it's kind of the right thing. And so they fall into three categories, and those are human generated. There's issues involving economic crisis, recession, unemployment, sort of the standard economic terms. The unemployment, I already mentioned that. Student loans, that was a big deal on whether, I mean, still a big deal, whether you have enough money to buy a car. And then all sorts of consumption, travel, birthdays, carpooling, all of those are potential predictors. And I would use this model to say controlling for the time series variables. These are candidates for being predictors in my regression, okay? And then there's something for jobs down there at the bottom. And this is basically, we use these economic relevant terms as predictors, not so much because it couldn't find good predictors, but all of the terms are like hundreds of them. And it's just sort of wasted computer time that they're going to end up picking from this table anyway. Yeah, so that was the time series stuff, but you can also do the same thing for cross section. And here's a nice little example. This is from Ed Glazer, had a little paper on where are the happiest cities in the US. And it turns out there's an ongoing CDC behavioral risk factor survey that says, how satisfied are you with your life? That's kind of a proxy for how satisfied are you, how much, what kind of queries are predictive of happy and unhappy cities. So there's a little picture of it. You can see they're kind of unhappy down there in the south. You look at this area, but people are really happy out here in California and some of the places along the East Coast. You can see what this picture looks like. It's interesting to look, interesting to play around with that. Again, just using conventional tools, it's something where there's insights to be had. So I said, okay, what's the probability of inclusion in a regression for happy cities? So there's no time series stuff here. There's pure cross section. And it turns out if there are a lot of queries on gambling, pretty likely to be an unhappy place. Okay, and that's not Las Vegas glory gambling with all this stuff. This is lotto. I found out by looking at trends data that was more, that had that category in as a separate category. And manufacturing, same thing. It's a Rust Belt story. Coupons, discounts. Well, again, that's a sign that you don't have a lot of money, so you're using a lot of coupons. And toys. I gotta say, I don't know why toys is in there, but I think it's a spillover from gambling. That you can do something that, depending on how you define the query and how, as the category of the query, it's certainly possible that they have something in common. And then the rest of them, well, home furnishings, health insurance, and so on. So you can see not only what it is that's predictive of these happy and unhappy cities, but it gives you kind of a thinking about where you might go in terms of measuring consumer welfare using these consumption categories. So it was kind of an interesting thing to do that you could extend in various ways. All right, this one is about Google surveys, and I'm sorry to say we had this great system for doing surveys, which I found very attractive, and then we shut it down because it wasn't getting enough marketplace traction. So you can't do this, but there are other survey services on the web which you can do, and I assume that you could use those if you wanted to do it. So this is how our system worked. You ask a question, a survey question online, and then what happened is if you answered the question, you were allowed access to premium space in the publication. So you've all seen this. It says, click here to continue reading this document. This was providing access to those documents using this survey mount. And you say, well, answer my survey question. Yeah, I'll let you read that extra content. All right, that's not too important, but it'll explain some things that pop up in a minute. Oh yeah, well, here's an example. This is a search over here as really a survey question. And over here, you're looking at choosing you know, usual information about what that survey looks like. So is this any good? Well, this is a picture from Pew. That's a really highly respected survey policy organization. And then what Google Trends, not Google Trends, but what Google surveys get. And they ask people, if you were asked to use one of these commonly used names for social classes, which would you say are you? Middle class, lower class, upper middle, etc. And if you look at that survey results and compare it to the Pew, you get really good alignment. So this case, the survey methodology has worked pretty well. And I have other charts like this. So now what's neat about that is anybody can do the survey. You don't need a great big infrastructure to do it. The cost is dramatically lower. This was about 10 cents per response. Results came back in a few hours. You can look at other people's surveys and see if you could replicate them. That's very nice. And it's not a random sample. Sorry, can't help it. It's not random, but it seems like it works pretty well in terms of surveys where it is a random sample, which is what we care about. So here's an example. We ask this nice little attitude question. I prefer to buy products that are assembled in America, right? So that's the query, that's the survey question. And down here, there's a list of people that strongly agree, neutral, mildly agree, and so on, usual story. And now we'll look at the predictors. So what are the predictors of that? Yes, you can see some people get it before others here, but you see the big query was Chevrolet, firearms, country music, trucks, kitchen. I mean, it was things that fit with the stereotype that we think of in terms of certain places. And in fact, if we look at a chart, we can see where that places are, which is basically Appalachia, I guess. I haven't spelled it all out, but you can see here's the Rust Belt up here with Michigan, Ohio. Here's the area we're seeing those attitudes being very likely responses to the survey. So that pretty interesting chart, I think. Oh yeah, and these are the top and bottom cities. If you look on the left, you can see where they're the most, not dissatisfied, where they're most aligned with the question of I prefer to buy cities in the US. You've got the top places, which are all over here in the South, and then the bottom, which is in California. Now you've got Mountain View, San Jose, Berkeley, Redmond, Palo Alto, and so on. So shows you a huge division in terms of attitudes towards foreign trade by these different regions. Okay, so yeah, here's a more recent one. I mentioned we worked on the data in terms of COVID traffic, but this is one about the stimulus check. And so the stimulus checks came out. There's a big debate. Where are they going to? People are going to spend them, and they're not going to spend them. They're going to pay down their credit card and all sorts of things. Well, here you could run a survey in a matter of minutes, really. And within 24 hours or so, you could look at how people would respond to the rebates. So things where you get sort of instantaneous feedback. Yeah, and this is something we did, same general idea using Google and Facebook's symptom survey. So this was quite interesting. We worked with some people at Carnegie Mellon on this, and they had done a lot of work on flu prediction, not necessarily COVID, just regular old flu, and had a lot of experience in terms of what was helpful in those contexts. We're looking at surveys of MDs, but then also of general population. So we came out with a question for this survey. Do you or anyone in your household have a fever of at least 100 degrees, along with cough, shortness of breath, and difficulty breathing? That was the original question. We got some nice data flowing in with people answering that question. And you compare that question to the geographic location of COVID. But Alas, our human subjects committee said, no, you can't ask that question. It violates privacy. Well, this was a very big disappointment to us. It was helpful in terms of prediction. So we said, well, wait, can you do something that's a quasi query, or what do they call it now? I forgot the name of it now. A query, a proxy query is the term that's used by the survey people. You're not asking directly something about you, we're asking about somebody else. And in this case, do you know of someone in your community who blah, 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 same completion. And yeah, it was second best, but we figured better than none. We ran it through our prediction models. It was better. It was a better predictor than what we used before. And you can sort of see that from these charts. The click in from Google Surveys is the one on the left, and the other one without that is on the right. And it turns out this is something that survey people know. I didn't know it, but it's worth knowing, even if they're an amateur. Because suppose you look at something that has a very low probability, like are you buying a new car? Maybe that you get 2% of the population, maybe 1.5% of the population who might be in that category. But it's much better. Do you know of people in your community or your friends that are buying a car? You get a much better picture. You're not getting the absolute numbers, but you can do the comparison across states. And so those proxy questions are really can be quite powerful, even without this privacy advantage that they have. And it's something that what's nice in our context, you can find out, is this a good predictor or is this not a good predictor? So we can just find out whether it's something that's going to be included, or we can let the computer do it for us in terms of picking the variables that are the most predictive. So that was a new finding for me, and I'm almost at the end here. I'm going to talk for just very quickly about causal inference and how this fits into that framework. So what happens is one of these lines, the red line, is our estimate of what, in this particular case, it would be click-throughs, which click-throughs were in fact the most predictive. Well, let me try this again. We can build a model where we've got the counterfactual, so that happens if there's no treatment at all. And then we've got a model that we estimate, we train that in the first quadrant there. Then we test it out of sample to ask, is the out of sample prediction aligned with the outcome? And then in the period 3, we have a treatment, and you can say, hey, look at that. Those people had the treatment, this metric, click-through rates or whatever it is, went up dramatically. And then test, we turn off the system, we're going to advertise less, and then it goes back down to where it was. Okay, so you've got this really nice picture where we've got train, test, treat, and then maybe another test if you've got something going on at the end of the period. So everything depends here in having a good prediction of the counterfactual. That is, the people that didn't get any treatment, was their spending higher or lower, whatever. Here we're finding that this advertising campaign that is there in the third quadrant. We find that the treated group is much more responsive than the untreated group. Okay, and there's a package we have called causal inference. There's some output from causal inference, which is a beautification of the charts that I just showed you. In this case, there's intervention, so we haven't done anything there in that first third, and then we apply the intervention, and then we see how much more that boost that gives you than if they hadn't had the treatment. So that's kind of handy. Now, this isn't dealing with the exogeneity question. This is a test where we're turning on the treatment and turning off the treatment. We don't have to infer what was done in a fully causal model, but it's kind of handy and produces this really nice charts. And it uses, I should say, the technology I mentioned earlier for finding the predictors that are the most helpful in looking at the outcome of the process, the fact that you've got this response that's going on. It's often very good at identifying why that's happening, or at least finding a good reason why you think that's happening. Okay, so that's it.